In 2006, we threw it away. We took a vote, scientists in a conference room, hundreds of light years away from the subject of their debate, and decided that Pluto was not worthy, not a planet, a dwarf, a leftover, a piece of frozen debris drifting at the dark edge of everything. We stopped teaching it to our children. We erased it from the maps. We were wrong. Because in 2015, when we finally sent a spacecraft to look at what we had discarded, 9 years of travel, 3 billion miles of empty dark, what we found was not a dead, frozen rock. It was a world, active, strange, and deeply, quietly terrifying. The first images arrived on July 14th, 2015, and they were beautiful. A pale world, smaller than our moon, drifting alone at the edge of the solar system, where sunlight arrives 500 times dimmer than on Earth, where noon looks like deep twilight, where the temperature drops to minus 230 degrees Celsius, cold enough to freeze nitrogen solid. And there, stretched across its equator, was a heart, a giant, pale, perfectly shaped heart, nearly 1,000 miles wide, glowing against the dark surface like a symbol written by the universe itself. The media ran with it, a cosmic Valentine, proof that even at the edges of the solar system, beauty exists, hope exists. Do not be fooled. That heart is not a message of love. It is not a symbol of anything gentle. It is one of the most geologically violent structures in the outer solar system, a wound filled with boiling poison, and it has been slowly consuming everything around it for billions of years. Pluto is not what we thought it was. It was never what we thought it was. The heart has a name. Scientists call it Sputnik Planitia, a glacial basin roughly the size of Texas and Oklahoma combined, carved into Pluto's surface by an ancient impact and filled over billions of years with a churning ocean of solid nitrogen, methane, and carbon monoxide. Not water ice, nitrogen ice. A different kind of cold entirely. Deep beneath this toxic glacier, Pluto's core still holds trace amounts of radioactive heat, a faint warmth left over from the birth of the solar system, slowly leaking upward. This heat causes the nitrogen to convect, to boil in slow, enormous cells, each one hundreds of kilometers wide, turning over like the surface of a pot on a stove. This constant motion erases any evidence of asteroid impacts. Any space rock that hits Sputnik Planitia is swallowed, pulled beneath the churning surface, dragged down into the frozen depths, and erased. The basin is pristine, perfectly white, because it consumes everything that touches it, a sea of poison that eats the sky. And at its edges, something stranger still. The nitrogen glacier is denser than the water ice making up Pluto's mountains, so the mountains do not sit on the ground. They break loose and drift, floating across the toxic sea like icebergs, mountains the size of the Alps moving in slow silence across a white ocean of frozen poison. Imagine watching a mountain range drift toward you. You would not run, there would be nowhere to go. But look closer. Look at the peaks of those floating mountains. The snow is wrong. On Earth, mountain snow is white, frozen water reflecting sunlight. On Pluto, the peaks of the ice mountains are capped with something dark and reddish, like rust, like old blood, like a stain that does not wash away. This is tholins. When the faint ultraviolet radiation from the distant sun strikes the frozen methane and nitrogen on Pluto's surface, it triggers a chemical reaction. Complex organic molecules form, hydrocarbons, nitriles, structures of carbon and hydrogen and nitrogen that do not exist in significant quantities anywhere else in the inner solar system. These compounds are reddish-brown. They drift down from the upper atmosphere like a slow, eternal rain, coating every surface they touch. It snows on Pluto. The snow is dark red. It falls from a black sky. It never stops. Tholins are not just cosmetically strange. They are chemically significant. These same organic compounds, formed by radiation striking simple molecules, are believed to be among the building blocks of life, amino acids, the precursors to proteins. Pluto's surface is covered in the raw materials of biology, not life itself, but the molecules that, under the right conditions, with liquid water and energy, can become life. There is no liquid water on Pluto's surface. The temperature is far too cold. But then scientists looked deeper, and what they found beneath the ice changed everything we thought we knew about where life can hide. Here is the problem with Sputnik Planitia. It should not be where it is. The nitrogen glacier in Pluto's heart region is enormously heavy, a mass of compressed ice sitting off-center from Pluto's equator. That kind of mass imbalance should have caused Pluto to rotate, to roll over millions of years ago, repositioning the heavy basin at the poles, where the gravitational geometry is more stable, but it did not roll over. Sputnik Planitia has been sitting in roughly the same position for billions of years. The physics do not work. Something is acting as a counterweight, deep underground, directly beneath the basin. Something heavy, something that should not be there. The leading explanation, supported by multiple independent models, is a subsurface ocean of liquid water, a global or regional ocean kept from freezing by the pressure of the ice above it and the trace radioactive heat leaking from the core below. An ocean potentially hundreds of kilometers deep, sitting beneath 150 to 200 kilometers of solid ice. On the surface of Pluto, the temperature is minus 230 degrees Celsius. Sunlight is 500 times dimmer than on Earth. It is as cold and dark and inhospitable as anything in the solar system. And beneath the surface, liquid water, in the dark, in the silence, possibly warm enough, barely, to support chemistry, possibly warm enough to support more. Could something be alive in there? We do not know. We have never looked. We do not yet have the instruments to look. But the question has been asked, and it has not been answered. That is the most terrifying sentence in science. Not. We looked and found nothing. But we have not yet looked at all. Everything we know about Pluto came from one mission, one spacecraft, 9 years of travel, one flyby, 12 hours of close observation, and then it was gone, continuing outward into the Kuiper Belt, never to return to Pluto again. New Horizons passed Pluto on July 14, 2015. It gave us our first clear images of the heart, the mountains, the red snow, the thin blue atmosphere glowing at the edge of the planet as it eclipsed the sun. It gave us more data in those 12 hours than all of human history had collected on this world combined. And then it left. We have been analyzing that data ever since. New papers are published regularly, discoveries still being pulled from a decade-old flyby, from a spacecraft that is now more than 8 billion kilometers from Earth and still moving. There is currently no approved mission to return to Pluto, no orbiter, no lander, no probe. Scientists have proposed one, a Pluto orbiter that would spend years mapping the surface, studying the atmosphere, scanning for evidence of the subsurface ocean. The science case is overwhelming. The mission has not been funded. We know there is a liquid ocean potentially hiding beneath Pluto's ice. We know there are organic molecules on its surface. We know it is geologically active in ways we do not fully understand, and we are not going back. Not yet, not soon. Pluto sits at the edge of the solar system, doing extraordinary things with no one watching. We dismissed Pluto. We voted it out of the family, reclassified it, stopped teaching it to our children as though it had ceased to matter. And all the while, 3 billion miles away in the dark, it continued. Its nitrogen glaciers kept churning. Its mountains kept drifting. Its red snow kept falling through a pitch-black sky. Its hidden ocean, if it exists, kept holding whatever it holds in complete and ancient silence, waiting for a visitor that has not come. There is something profound in that. Something about the arrogance of classification, about assuming that because we have named something, diminished it, moved on from it, it has ceased to be remarkable. Pluto does not need our validation. It was extraordinary before we arrived. It has been extraordinary for 4.5 billion years. It will be extraordinary long after the sun has expanded and consumed the Earth, and the last human memory has faded into nothing. It is the exiled king of the outer solar system, and it rules its frozen kingdom with or without our attention. Keep looking up. The things we have discarded are often the things most worth finding again.